Okay, let's fire through this electricity assignment. So we got first question here. What is the current of circuit of 250 coulombs of charge pass through every 2 minutes? Well, current is basically just how many coulombs go by every second. So I have 250 coulombs in 2 minutes is 120 seconds. That works out to 20.83 coulombs every second, or amps. What's the voltage? Voltage says how much energy is every coulomb carrying. So I have 4,200 joules of energy being carried by 38 coulombs. So 4,200, that's 110.5 volts. And then we got the other formula, power equals VI. So I know the power is 55 watts. The voltage is 12. And they want me to find the current. Rearrange that. 55 divided by 12 is 4.583 amps. And they also know good old Ohm's law. V equals IR, or R equals V over I. So I got voltage is 12 volts, and the current is 4.583. Gives me a resistance of 2.618 repeat ohms. Okay, next question says, if you connect the same light bulb into 120 volts, what would the power be? So we're going to do this whole question backwards. So we got to get current. I equals V over R. And we're going to jump the voltage up to 120 over 2.6. I got that number still in my calculator, so I don't have to. So that'll come out to 45.83 amps. And power equals VI. So now we got 120 volts. Amperage is 0.583, which is a 10 times increase. So we not only doubled one of these numbers, both of them wound up being doubled. So that light bulb is now 5,500 watts. It's designed to get rid of 55 watts of energy, so that's light bulbs. Oh, here he goes. What's likely going to happen to the light bulb? I think it's probably not just going to burn out, it's probably going to blow up. Because that's so much more energy than it can handle. Okay, we got 3 resistors in a box. Draw the sketch below. Okay, we're going to connect them all in series. Resistor, 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 and it's a 24, a 12, and an 8. So here comes Mr. Electron, says, hey, I want to go through there. It's going to have to travel through all of them, so it's going to feel all that resistive force on top of each other. So 24 plus 12 plus 8 works out to 44 ohms. Let's connect them in parallel. So then we're going to have here we have this type of system where the electron coming in here has a choice. Okay, you can either go through the 8 and out, or go through the 12 and out, or the 24 and out, which actually makes this whole circuit a little bit easier. If we just had the 8, everybody would be going through the 8. Now I add an additional trail and another additional trail. We're going to get more electrons going through this, which means it's easier to get from here to there. You have to use that inverse rule, though. And the algebra people will be going, oh, awesome. 1 over 24 plus 2 over 24 plus 3 over 24 is 5, 6 over 24. 24 divided by 6 is like 4. Or I just do it in your calculator. I go 24 inverse. There's a little button that says 1 over x. I'd go 12 inverse, and I'd add those two together, and then I'd go 8 inverse and add that into the total, and I get 0.25, and then I inverse that. My total equals 4 ohms. Okay, any combination of your choice. Okay, well, let's just do an 8, and then I'll split. I'll put the 8 ohm out here, and I'll put the 24 ohm here, and the 12 ohm there. So I have to find this group. So 24 inverse, 12 inverse, add that together, invert that is 8. So this whole package here is an 8 ohms. 8 plus 8, 16 ohms for the total. Okay, Christmas lights. If one burns out, that means they gotta be in series. Because if I break a circuit here, then nobody gets through that one anymore. Okay, so it's series. How much voltage each one gets? Well, let's see, the voltage will be split up between all 70 of them. So 120 divided by 70 works out to 1.7 volts each. Okay, so you make a much cheaper light bulb that can handle less voltage. But then it's a problem. If it burns out, you gotta find the one that burnt out. Okay, vegetable farmer. He wants to get a head start in his pepper growing business. He uses 10 400 watts, so his power would be okay, he's running 4 kilowatts. And the time is 12 hours a day. Oh, for 75 days though. Let's see how long he's got them on. 12 times 75. He's going to be running 900 hours of light bulb use at 4 kilowatt hours. The cost is 14 cents. The formula is actually the unit. It's kilowatt times hours. So a kilowatt hour is just the kilowatts times the hours. So we use 3,600 kilowatt hours at 14 cents each. Let's multiply that out. That guy spent $504 to get his peppers growing. So hopefully he's got a lot of peppers. Must be a big garden. Let's go through this one. Let's fill in. Let's do the old red thing here. So R1 is 10 volts, 2 ohms. Don't know anything about R2. R3 is 2.5 amps and 5 ohms. And this one is 15 ohms. Come down to the bottom. Nothing about that guy, but I know 3 amps are taking that trail and 120 volts for the total. So let's take what we know. I got 2 numbers here. So we can do V divided by, so V-I-R. So I can get I here. It's going to be V divided by R. So 10 divided by 2 is 5 amps. Okay, now we know how much is coming out of here. This will be 5 amps. 5 amps comes up here. Splits apart, joins back together. So the saved 5 amps are coming by here. They're going around the circuit. They were nice enough to say that 3 took that way. If 3 took the bottom trail, that means 2 amps must be taking this one. If 2.5 takes the bottom trail, that means 2.5 are also taking the top trail. Okay, so we got all the numbers for this one. I got 2 numbers here. I have current, I can get V. V is I times R. V, oh, we also know this guy would be 2.5 amps, because if the 2.5 go by here, same 2.5, join back together to 5, we can get these 2 voltages here. So 2.5 times 5 is 12.5 volts. And this one here would be 15 times 2.5, which would be 37.5 volts. And whatever this side is, that side has to be. So if I add them together, this works out to be 50 volts. Okay, now we have this side is 50, that side's 50, because the electrons that go this way get the same as the ones that go that way. We can get the resistance on that side, V over I, so 50. That's 20 ohms, but look what this side was. 5 and 15 is also 20. 20 ohms on this side, 20 ohms on this side. That's why it's split perfectly in half. Okay, so we got, this is 10 volts, this is 50 volts. They get 120 on the way out. So I lose 10, lose 50, I've lost 60. That gives me 60 volts to lose whether I go this way, and 60 volts for those guys. Because either way, I have to lose 120, come back with nothing. So I go 10, 50 plus 60 is 120. 10, this plus this is 50, plus this 60 is 120. I come back with nothing. So the only thing I need to get here is resistances. R equals V over I, so 60 divided by 3 is 20 ohms. 60 divided by 2 would be 30 ohms. That's a 2 to 3 ratio. And look at the current. The current splits 2 to 3, but not in the same order because this is a resistance that tells you how hard it is to get through the circuit. So this side's harder than that side, which means it gets less current than that side. So even without the voltages, we could have got the currents just by doing ratios. This one here, magnetism. They're shoving the north pole in this way. This will become north, try to stop me. And if I'm pulling this magnet away, that'll become south to try to attract me and fight me, whatever I'm doing. And we're making electricity. There's no battery on here. So that's north. So if I go with the flow of electrons, you have to use the left hand. If we're American and talk about the conventional flow of protons, you have to go the other way. So my thumb is north. My fingers are going up this tube and down the back. So just gonna put some up arrows on that. That's all you need. Up the front, down the back. This one, north is gonna be over here. So if I was to grab that tube with my hand, my fingers would be going down the front if my thumb is there. There's no other way to grab it with your thumb. If your thumb is on that side, my fingers are wrapping around like that. So these would be down the front. Okay, let's take a look at this motor. This is positive, that's negative. I'm gonna show, oh, it just says current flow. So you could do it either way, but make sure, it should say conventional flow or electron. I'm going to stick with electrons because we know that's what's really moving. So my arrows are going to go down this way, through the battery this way, and then through all this stuff. We're going to have to trace this out. So it's coming in here, it contacts here, goes this way, goes around these coils, all the way down here, underneath that one, and up the front again, and into this coil and out. So if I was to grab this with my hand, my fingers have to point. We can turn the page. My fingers have to go up the front, down the back. So this would become north. And this would be south. And what does north and north do to each other? They repel. So this motor will be pushed around this way. It spins around an axle here, like if my pencil was there, it kind of looks like that. Or spin. So we did the direction of the current, polarity on the armature, and the direction of the motion, so it's going clockwise. Last question here, we've got transformer. I've got a little picture. Put a bunch of coils on that side, a bunch of coils on that side. This is the primary side. Let's see. So it's going to take 120 volts at 15 amps. The number of coils on the primary side is 36,000. And we're going to drop this down to 15 volts. Okay, so this number here is going to be much less than that one. So if I look at the ratio of the voltage, that's going to equal the number of turns, but it's going to be upside down for the current. So this will be secondary here, and this will be primary. Current's backwards. But I got the voltage. The ratio of the voltage is 120 in, 15 out. So I go 120 divided by 15. That's an 8 times drop. So this is like an 8 to 1 ratio, which means the coils will also be an 8 to 1 ratio, and the current's going to be a 1 to 8 ratio. So the current's going to jump way up. So if I divide by 8 to get that, I multiply by 8 to get that one. So that's going to be 120 amps. And this thing here would be divided by 8, so 36,000 divided by 8 is 4,500 coils wrapping. So this would be much tighter wrapped on this side. This would be like making a welding machine. Maybe it says that, yeah, welding rods. So 120 amps would definitely melt anything you stick in there. Power equals VI. You'll notice it's only one mark because the input and the output have to be the same. So here it'll be 120 times 15 is 1800 watts on the way in. This would be like in. If we do out, it'll be VI again, but the voltage now is 15. And this is 120. Those two numbers have switched, but it's exactly the same number. Okay, because power in a transformer always equals the power out.